World War II lasted just shy of 6 years. In the grand scheme of world history, that is just a blink of an eye. But in that short time, engineers on both sides created hundreds, if not thousands, of different combat aircraft. They were constantly trying to outdo each other in the sky. However, only a handful became true legends, capable of turning the tide of battle. Interestingly enough, almost all the most famous aircraft that really shaped the war were designed in peacetime. This happened well before the shooting started. For instance, the famous British Spitfires, Japanese Zeros, and German Bf-109s earned their legendary status precisely because they were developed without being rushed. Engineers designed them right from the start with massive, built-in potential for future upgrades and modernization. Of course, there were some notable exceptions. Fighters like Kurt Tank's FW-190, Semyon Lavochkin's Soviet La-7, and Willy Messerschmitt's jet-powered Me-262 hit the front lines right in the thick of the fighting. But even they relied heavily on the massive engineering and manufacturing infrastructure. Their countries had carefully built this up well before the first shots were fired. From the very beginning, the Axis powers went all in on aggressive tactics and total air superiority. Because of that mindset, they completely ignored an entire class of aircraft. These were the dedicated interceptors. They had not laid any groundwork for mass-producing them before the war. And that overconfident mistake eventually proved fatal. Every attempt to quickly shift their aviation industry onto a defensive footing fell apart. They simply did not have the right factories or technology in place. This failure ultimately contributed to their overall defeat. But it is important to understand that they did try to course correct. And the story of the aircraft we are diving into today was born out of one of those desperate attempts. Now, it is a common misconception that the Imperial Japanese Navy Command realized their mistake way too late. People often think they only ordered a new land-based interceptor at the last possible minute. In reality, their very first military setbacks in the Pacific forced Japanese admirals to seriously consider building this type of aircraft. This happened long before massive bombing raids by American aircraft began devastating the Japanese home islands. As far back as 1938, Mitsubishi received an official requirement to develop a new single-engine land-based interceptor. But since the Japanese Navy did not feel any pressing need for that kind of aircraft at the time, the development process was constantly pushed to the back burner. The engineering team missed every conceivable deadline. It was not until early 1942 that the company finally rolled out the first prototype. At first, the military brass was pretty disappointed with the results. But after a series of major overhauls, the aircraft was accepted into service. It was given the name Mitsubishi Raiden, which translates from Japanese as thunder. To be fair, this fighter would eventually become one of the most effective aircraft in the Navy's arsenal. For a long time, the Raiden was the only land-based interceptor that the Japanese aviation industry managed to produce in any significant numbers. This remained true right up until the introduction of Kawanishi's new fighter, the Shinden, meaning violet lightning. As the war dragged on, the existing requirements for combat aircraft quickly became obsolete. So in 1942, the Navy's Aviation Bureau decided not to waste any more time. They initiated the development of two brand new projects simultaneously. The military needed a modern, blisteringly fast, single-engine, land-based interceptor. It also had to be optimized for short to medium ranges. This incredibly tough job was handed over to the designers at Kawanishi. There was just one problem. Most of the company engineers were already tied up with another ambitious project. Completely on their own initiative, they were working on the Shinden interceptor. They were actually developing it from a seaplane. This was the Kyushu floatplane fighter, which means strong wind in Japanese. At the same time, they were hard at work on a heavily upgraded version known as the Shinden Kai. The irony was that this new aircraft did not meet the updated military requirements at all. However, when it came down to actual test flights, the results deeply impressed the Navy's evaluation board. They were so impressed that the project was greenlit without hesitation. The Shinden Kai would go on to make history as one of the finest combat aircraft of the Imperial Japanese Navy. Together with the Raiden, these two fighters would essentially form the backbone of the interceptor force in Japan right up to the end of the war. However, this side project severely disrupted deadlines for other government contracts. As a result, engineers at Kawanishi completely blew past their established schedules. Work on the J3K1 interceptor project had to be shut down in its early stages. It was deemed a dead end specifically because of the constant development delays. A second ambitious project was the J6K1 aircraft. It was named Jinpu, which translates from Japanese as squall. This project met a similarly sad fate. It never even reached the flight testing phase. In fact, it was officially canceled during the final assembly of the first prototype. Interestingly, this was the very airplane that had every chance of becoming a main competitor. It was meant to rival the J7W1 Shinden in the fierce battle for mass production. The second, and frankly the primary competitor, was an interceptor project from Mitsubishi. This was the J4M1 Shinden. Here's a fun fact. Both participants in this engineering competition received almost identical names right from the initial development stage. They were similar in both how they sounded and what they meant. The J7W1 Shinden translates to magnificent lightning. Meanwhile, the J4M1 Shinden means shining lightning. In early 1944, the Navy leadership tasked Mitsubishi with creating a single-seat, land-based interceptor. However, work on the project moved incredibly slowly. The main reason was the massive workload piled onto the company's engineering teams by other projects. As a result, the initial blueprints were only ready by January 1945. And on top of that, the aircraft itself never materialized as a working prototype. Despite all this, the story of the J7W1 would be incomplete without mentioning this aircraft. And it is not just because they were intended to be main rivals. Aside from their similar lightning-themed names, both aircraft had a lot in common technically. First and foremost, both featured highly unconventional aerodynamic designs. These designs had barely been seen anywhere else in the world at the time. What's more, both airplanes were slated to use the exact same powerful engine. It was mounted in the rear of the fuselage, driving a massive 6-blade pusher propeller. Engineers at Mitsubishi proposed a truly unusual design for the era. This was perhaps due to the heavy weight of the 18-cylinder, air-cooled Mk9D radial engine. This engine was also known as the Ha-43. Whatever the reasons may have been, they decided to build the aircraft using a twin-boom layout with a central nacelle. The cockpit was positioned at the front of this nacelle. The engine and 6-blade propeller were sitting right behind it. Finally, a single horizontal stabilizer and elevator connected the two tail booms. They wanted to make the front of the cockpit almost completely transparent. This would give the pilot perfect forward visibility. The main landing gear struts were designed to retract into the two tail booms. Meanwhile, the nose wheel tucked right under the cockpit itself. That same central pod was also meant to house some serious firepower. It contained one 30mm cannon and two smaller 20mm cannons. Interestingly, around the same time, another Japanese company called Manchu was developing the KY-98 Army ground attack aircraft. They were using the exact same aerodynamic layout. They even managed to get this airplane to the prototype stage. However, it was never finished because the war ended. On top of that, a similar design had already been successfully tested in Sweden on Saab J-21 fighters. These were gearing up to enter service. Right from the start, just like the Japanese did with the Shinden, the Swedes designed the aircraft with a specific goal. The piston engine could eventually be swapped out for a jet engine down the line. Was there any direct engineering collaboration between these projects on opposite sides of the world? It is incredibly hard to prove now. However, you cannot entirely rule out the possibility. Ultimately, the Mitsubishi design department was falling disastrously behind schedule with their J4M1 project. Because of this, the Navy brass took an unprecedented step. They simply canceled the Mitsubishi project. Then they ordered the competing Shinden into mass production. And they did this without even waiting for the flight test results. In fact, they ordered it before the first prototype was even fully assembled. The main reason for such a hasty decision was likely that the Kyushu factories had more available capacity. They were not as swamped with government contracts as the industrial giants over at Mitsubishi. The last aircraft intended to become the new land-based interceptor was an ambitious project from Mitsubishi. This was the A7M3J Repu, which translates from Japanese as hurricane. However, it never really posed a threat to the famous Shinden. The Japanese Navy leadership had hoped to put the Hurricane into mass production right alongside the J7W1. They viewed it as a sort of insurance policy. It served as a backup airplane in the exact same class. But reality got in the way. Work on the project had to be permanently shut down while the first prototype was still being built. This happened simply because the war ended. Meanwhile, Japanese designers were not just sitting around. They were working on other interceptors at the same time. For instance, engineers at Nakajima were actively developing a twin-engine aircraft. This was called the J7W1 Tenrai, or Heavenly Thunder. This fighter was supposed to replace the frankly outdated J1N1S Gecko interceptor known as Moonlight. But those high hopes fizzled out. When the prototype was finally finished, it completely failed to meet any of the primary technical requirements of the military. At those same Nakajima factories, another really fascinating project kicked off in 1944. This time, the Japanese set out to build a twin-engine jet interceptor. It was the J8N1 Kika, which translates to orange blossom. They based this aircraft on the legendary German Me-262A1 Schwalbe. The concept looked promising, however, it never made it into mass production. The main problem came down to constant delays in delivering the NE-20 turbojet engines from Nakajima itself. The first working examples of these engines were not assembled until late July 1945. This was simply too late for Japan. Right around that same time, in July 1944, Mitsubishi received an urgent requirement to develop a single-seat rocket-powered fighter for the Navy. This time, the inspiration was another German aircraft, the Me-163 Comet. The new Japanese project was given the bold name J7W1 Shusui, meaning sharp sword. Alongside the Navy, the Imperial Japanese Army also took an interest in the aircraft, adopting it under the designation KY-200. However, history repeated itself. Not a single one of the prototypes ever managed to successfully complete a full flight test program. Here's the bottom line. During the closing stages of the war, the Japanese Navy simply did not have a new interceptor rolling off the assembly lines in large enough numbers. They desperately needed more to fully replace the J2M Raiden and N1K2J Shinden Kai. They desperately needed an airplane that could go toe-to-toe with the latest American warplanes. As for the Raiden and the Shinden Kai, despite all their undeniable combat strengths, they started showing their age rapidly. This happened right around the time the Americans launched their massive bombing campaigns against the Japanese home islands. When you look at the hundreds of different aircraft designs developed by Japanese engineers during the war years, many of these became legendary worldwide. But compared to them, those few half-hearted attempts to build a capable interceptor look, quite frankly, pretty feeble. Still, despite all that, the J2M Raiden and N1K2J Shinden Kai left a strong and lasting mark on the history of World War II. On top of that, there is at least one Japanese interceptor design that absolutely deserves to stand right alongside those fighters. It even deserves its place among the most famous aircraft of the era. So let us talk about the Japanese Kyushu J7W1 Shinden. Today, there is really no point in debating whether this fighter could have impacted individual battles. It is also pointless to wonder if it could have changed the course of the war if it had just shown up a little earlier. If we put fantasy aside and stick strictly to the objective facts, we can say with near certainty that it would not have. However, even though this aircraft never made a massive impact on the battlefield, it permanently cemented its name in aviation history. This airplane was the true embodiment of the incredible leaps in aviation design taking place at the time. The Shinden never achieved the legendary status of fighters like the famous Zero or the K-161. But if you take a closer look at this aircraft, which at first glance is very bizarre looking, you cannot help but start imagining alternate timelines. You find yourself wondering how things would have played out if history had gone a different way. And that makes total sense. Its unusual, almost sci-fi shape for the time immediately grabs your attention. Then, when you picture this somewhat awkward-looking airplane soaring high in the sky, it becomes incredibly hard to believe. It is hard to believe that an aviation masterpiece like this would not come out on top in a dogfight. Unfortunately, we are left to just guess what heights, both literally and figuratively, this fighter could have reached. This is because its combat career was cut short before it even got off the ground. The story of the creation of the Shinden goes all the way back to early 1942. That is when the Imperial Japanese Navy Technical Bureau tasked designers at the Technical University. Their goal was to develop a fundamentally new, highly advanced, and incredibly fast interceptor. They handed the job over to the university specifically because the project was a relatively low priority at the time. The university specialists were not bogged down by urgent frontline demands. This gave them plenty of time to focus on quiet, in-depth, fundamental research. Soon enough, though, the military decided to kick the process into high gear. To help out the scientists, the 1st Naval Air Technical Arsenal assigned a dedicated team of developers to the project. This arsenal is better known around the world by its acronym Kyushu. This team was led by a talented naval engineer and pilot, Captain Masayoshi Tsuruno. It was Captain Tsuruno who came up with the bold idea to build a new fighter. He used an aerodynamic layout that was completely innovative for the time. This is a design known today as a canard configuration. Today, decades later, this kind of layout is common on many modern aircraft and guided missiles. But by the end of the Second World War, only 3 aviation projects in the entire world featured such an unconventional configuration. The Shinden can rightfully be considered one of the first fully realized aircraft to use this canard design. The term canard comes from the French word for duck. It is easy to see why early aviators made the connection. Just picture it. It has a long neck with a blunt nose, a bulky fuselage, and relatively short wings pushed almost all the way back to the tail. The very first early version of this project was developed under the experimental 18 Shi specification. Naturally, at that point, the designers did not have any practical data. They did not know how an aircraft with such a radical design would actually handle in the air. So to test these new aerodynamics as quickly as possible, engineers at Kyushu were tasked with building a scaled-down test model. Working alongside specialists from the Yokosuka Arsenal, they were to run a full cycle of flight tests. This would let them see exactly how the canard layout performed in actual flight. This test glider was designated the Kyushu MXY6. By August 1943, 3 experimental prototypes of these gliders had been assembled. They were built at an aviation plant in the Kanagawa Prefecture of Japan, ordered by the Technical University. Their design was as simple as it gets. They featured an all-wood fuselage, fixed landing gear, and slightly swept wings. Vertical stabilizers were mounted on the trailing edges of the wings to maintain directional stability. But instead of a traditional tail, the horizontal stabilizers and elevators were mounted right up at the nose of the fuselage. The flight test program of the glider got off to a successful start. In early 1944, the Kyushu Arsenal conducted a few test flights with the MXY-6 gliders. They were fitted with small, 4-cylinder, air-cooled engines made by Nihon Ninenki. These produced 22 horsepower and drove a small-diameter, 2-bladed pusher propeller. But the top brass of the Navy was not about to wait around for the full testing cycle to wrap up. Time was rapidly running out in the war. As soon as the canard concept proved viable, the Navy Technical Bureau immediately ordered the development of the first 2 Shinden prototypes. This massive responsibility was handed over to the Kyushu Aircraft Company. Here's a fun fact. Up until 1943, this company was actually known as Watanabe. That is exactly why the letter W ended up in the J7W1 designation of the fighter. The company had absolutely no prior experience developing high-speed aircraft, but what they did have was available engineering capacity. This was something that was incredibly rare at the time. To help guide the project, the Navy decided to send over a team of specialists from the 1st Naval Air Technical Arsenal. Leading this group was the talented engineer Masayoshi Tsuruno. Kyushu officially kicked off work on the project in June 1944. On paper, it was simply listed as the experimental land-based high-speed J7W1 Shinden interceptor. And here's a key detail. Right at the very start of developing this new fighter, Masayoshi Tsuruno pitched a pretty bold idea. He planned to eventually swap out the standard piston engine for a cutting-edge turbojet. That forward-looking plan is exactly why the power plant was placed in such an unusual spot. It was mounted deep in the rear of the fuselage in a pusher configuration. The engineers at Kyushu were working on 2 variants of the aircraft almost simultaneously. The first was being designed around the Mitsubishi Mk9D piston engine. Meanwhile, the second was tailored for the brand new Ishikawajima Shibara NE-130 turbojet. Now let us look back at the exact reason the Shinden was developed in the first place. When Allied air raids on the Japanese home islands really started ramping up, local interceptors managed to hold off the onslaught for a little while. The sheer skill of the Japanese pilots allowed them to engage American aircraft pretty effectively. This was true even as their own fighters were starting to show their age. But that situation could not last forever. The number of American B-29 heavy bombers grew rapidly with every single raid. At the same time, Japan's pool of experienced pilots was shrinking at a catastrophic rate. Incredible high-altitude performance, heavy defensive armament, and unbelievable survivability turned the B-29 into a practically untouchable target. The numbers tell the story. During just one devastating raid on Tokyo on March 10, 1945, the Japanese managed to shoot down 14 B-29 bombers. Even though these were the heaviest losses the Americans had suffered up to that point, it amounted to a pitiful 4.5% of the total 302 aircraft involved in the operation. Meanwhile, over 85% of the designated ground targets in the city were completely destroyed. The Japanese Empire desperately needed a radically new interceptor. They needed an aircraft that could keep pilot losses to an absolute minimum. It also had to effectively tear through those massive American bomber formations. The High Command hoped this new airplane could inflict such devastating losses. They wanted the United States to be forced to halt the bombing campaign for good. The Shinden was supposed to be exactly that saving grace. The Americans built their B-29s for one specific purpose. That purpose was to reach the Japanese home islands from extreme ranges. In the exact same way, the J7W1 interceptor was designed exclusively to hunt down and destroy those flying fortresses. Driven by its chief designer, Masaoki Tsuruno, a specialized tactic was developed. This ensured the Shinden could intercept the American bombers as effectively as possible. The rationale was simple. The upper forward gun turret on the B-29 was remotely operated through a clever system of electric drives. However, it was only armed with two .50 caliber machine guns. Japanese military analysts realized this made it the least protected zone of the bomber. Because of this, they decided the best way to attack the giant superfortress was head-on and from slightly above. Thanks to its massive 30mm cannons, the Shinden could unleash devastating fire from well outside normal engagement ranges. However, a major problem came up during the calculations. In a direct head-on pass against the American bombers, the combined closing speed would exceed 745 miles per hour. At those insane speeds, the risk of a fatal mid-air collision was extremely high. To avoid this, pilots were instructed to come in for the attack at a slight angle. They would approach slightly above and off to the side. To maximize the chances of scoring a hit, the aircraft's cannons were harmonized, so the shells would spread out in a narrow fan pattern covering a wider area. The battle plan was simple but effective. As soon as early warning came in that enemy bombers were approaching, the interceptor would scramble. It would rapidly climb to roughly 39,000 feet to reach the calculated intercept point. Then it would dive on the B-29s. It would unleash a heavy burst of fire and pull hard into a steep climbing turn to set up for another pass. Making a second pass was absolutely vital. With such a high closing speed, the chances of actually destroying a bomber on the first try were pretty slim. To successfully pull off this bold design, the aircraft had to meet a few critical requirements. First, it needed incredibly high speed. This wouldn't just help it evade the bomber's defensive fire, but also let it outrun American escort fighters. Second, the interceptor needed a phenomenal climb rate. That was the only way it could intercept the speedy superfortresses on their approach. It had to reach them before they could drop their payloads on the target. Exceptional high-altitude performance was also an absolute must. But the biggest factor in making the mission a success was overwhelming firepower. Shooting down or even crippling these massive bombers was a very tough job. This was because the B-29s were notoriously rugged and packed heavy defensive armament. Standard 20mm aircraft cannons, which were considered formidable weapons right up until the end of the war, were becoming almost useless against armored giants like the Superfortress. Interestingly, the traditional hallmarks of Japanese aviation, like extreme maneuverability and long flight range, were deliberately treated as secondary for this design. While long range had arguably been the biggest trump card for Japanese pilots at the start of the Pacific War, it now had to be sacrificed. The new aircraft was designed exclusively as a point defense interceptor. Its sole job was to scramble quickly, strike, and return to base. The designers at Kyushu brilliantly met all the demanding requirements laid out in the military spec. At that desperate stage of the war, Japan urgently needed a unique fighter like the Shinden. Masaoki Tsuruno's concepts and blueprints looked so promising that the Japanese Navy Command decided to take a massive gamble. In May 1944, they ordered technical teams to start tooling up for mass production of the aircraft. The crazy part of the situation was that the military didn't just skip waiting for official test results. They didn't even wait for the very first prototype to be finished. The Empire's desperate situation simply forced them to fly blind and rush it into production. The mass production order was immediately split between two major aircraft manufacturers, Kyushu and Nakajima. By September, their factories were already preparing the necessary tooling. The military's plans were incredibly ambitious. Right from the start, they projected rolling out 30 aircraft a month on Kyushu's lines and 120 fighters at the Nakajima plants. The High Command estimated that between the spring of 1946 and early 1947, the Japanese Navy would add over 1,000 of these cutting-edge interceptors to its fleet. But reality turned out to be much harsher. Under continuous, devastating raids by American bombers, those grand plans remained nothing more than a pipe dream. The first prototype of this unique aircraft was finally finished in April 1945. It took a full 10 months from the moment the engineers received the initial military specifications. Compared to the baseline MXY-6 glider design, the developers introduced some highly significant and radical changes. First off, the Japanese designers focused on mounting some truly heavy firepower. They decided to pack the nose of the aircraft with a fearsome battery. This battery was made up of 4 30mm cannons. These weapons were incredibly bulky. Each cannon ran nearly 7 feet long and weighed over 150 pounds. Because of this, the engineers at Kyushu had to completely overhaul the shape and overall dimensions of the fighter's nose section. They had to noticeably increase both the length and diameter of the nose fairing. There was another reason for these major redesigns too. The nose gear strut was retractable, folding forward directly into the nose. As for exactly why the landing gear struts had to be made so unusually long, we will dive into that in a little bit. The cockpit itself also saw some noticeable changes. The production engine they went with was significantly larger than the earlier test versions. Because of this, the cockpit had to be moved forward. As a result, it sat right in front of the wing. This gave the upper rear fuselage a much more pronounced profile. The clear canopy was enlarged and featured heavy metal framing. On top of that, the engineers slightly increased the wing's overall area and sweep angle. They also tweaked the tail section. The main landing gear, just like the nose gear, was now fully retractable in flight. But the Kyushu engineering team had to tackle a major challenge while designing this aircraft. The biggest and toughest task was mounting the engine itself. It was the most powerful piston engine the Japanese aviation industry had ever produced up to that point. It gave the designers a real headache. The main issues were its massive size and incredibly heavy weight. Above all, there were some serious cooling problems. The thing is, up until this point, no one in the world had ever tried something like this. No one had mounted a massive 18-cylinder air-cooled radial engine all the way in the back of the fuselage. In any conventional aircraft layout, the cooling issue was handled in a very straightforward way, both literally and figuratively. The engine typically sat right in the nose of the airplane. It was constantly cooled by a massive rush of incoming air during flight. That airflow was usually more than enough to cool not just the engine itself, but several other crucial systems too. As for the world's most famous mid- and rear-engine aircraft, they did not run into this problem at all. These included the American P-29 Airacobra, the German Dornier Do 335 Feel, and the Swedish Saab J7W1. All of those aircraft were powered by liquid-cooled engines. This made things a whole lot easier. So this incredibly tough and seemingly impossible situation the Japanese designers found themselves in was solved with sheer brilliance. Sure, looking back on it decades later, this kind of engineering solution might seem pretty obvious. It might even seem like a no-brainer to a lot of people. But it is worth remembering that old saying, true genius lies in simplicity. Think about it for a second. Throughout the entire second half of the 20th century, most jet fighters and plenty of other aircraft were designed with this exact same air intake configuration. Yet, before the engineers at Kyushu, not a single aircraft designer in the world had ever tried it. Cooling air for the engine was fed through two narrow intakes. These were positioned flush along the sides of the fuselage. To really grasp the significance of this design, just picture what some of the most famous combat aircraft of the late 20th century looked like. You have got the Soviet MiG-25 and Tu-22M. Then there is the American F-15 Eagle and the Harrier, and of course the legendary F-4 Phantom. When you realize just how far ahead of their time the Japanese design team really was, you cannot help but be genuinely impressed. That said, we do have to admit that the airflow coming through these side intakes still wasn't quite enough to properly cool such a massive engine. Ultimately, this design flaw led to major temperature management issues. The engine was highly prone to overheating. This was especially true when the aircraft was flying at relatively low airspeeds. To give the aircraft solid high-altitude performance, the engine was equipped with a single-stage turbocharger. For Japanese engineers, this was a massive technological breakthrough. They had struggled right up until the end of the war to build a truly reliable high-altitude supercharger. The engine placement was highly unusual for the time. It was mounted right behind the cockpit in a pusher configuration. Using an extension shaft, it drove a massive 6-bladed propeller. This all-metal prop from Sumitomo definitely deserves its own spotlight. It had an incredible diameter of just over 11 feet. This made it one of the absolute largest props ever fitted to a single-engine aircraft of that era. Interestingly, in the event of an in-flight emergency, the designers actually built in a jettison system. This system would blow the propeller clear so the pilot could safely bail out. Speaking of the impressive record set by the Japanese Shinden, we absolutely have to talk about its firepower. This fighter boasted the heaviest armament of any single-engine fighter of the Second World War. In fact, its sheer firepower could easily rival even the heaviest twin-engine fighters of the era. For comparison, let's look at the famous German twin-engine jet. This was the Me-262 Schwalbe, which means swallow in German. Just like the Shinden, it was armed with 4 30mm cannons, yet its 1-second burst mass was only slightly heavier. The catch is that the German Messerschmitt was equipped with Mk-108 cannons. These fell short of the Japanese Type 5 cannons in muzzle velocity, projectile weight, and effective range. Engineers actually increased the standard ammo capacity for these cannons specifically for the Shinden. Instead of the usual 42 rounds, each gun on this interceptor held 60. The cannons were staggered in pairs. The top pair was mounted about 1.5 feet further back toward the cockpit. All that heavy firepower up front served another crucial purpose. It acted as a vital counterweight to balance out the massive engine and pusher propeller assembly in the rear. Down the line, they planned to upgrade the aircraft with even more advanced Type 17 cannons. These offered a much higher rate of fire and were already deep in development. The engineering team also mapped out a trainer version. Instead of heavy cannons, the training Shindens were supposed to carry 4 7.92mm sighting machine guns. These were paired with a gun camera system. Rounding out the weapons package, the fighter also had hardpoints under the wings. These could carry 2 60-kilogram, or about 130-pound, bombs, or 4 smaller 30-kilogram, 65-pound bombs. In early May 1945, a long-awaited milestone was finally reached. The engine was test-fired for the first time at the Kyushu Company's Haruta plant down in Fukuoka. Naturally, the engineering team ran into a few minor snags during the test runs, but overall, the review board declared the aircraft completely ready for flight testing. Once the technical bugs were ironed out, the fighter was carefully transported over to Mushiroda Airfield for its maiden flight. Unfortunately, that very first attempt ended up being a disaster. Picture the scene. The brand new fighter is rolled out of the hangar and the engine roars to life. Chief designer Masaoki Tsuruno decides to take the controls himself. The airplane starts speeding down the runway. Right at the exact moment the aircraft was supposed to rotate, the nose pitched up way too hard. The nose gear came off the ground, dropping the tail section. The blades of the rear propeller smashed into the runway with a horrific grinding noise. Tsurano reacted instantly, killing the engine and bringing the fighter to a halt. The aftermath was not pretty. The tips of the propeller blades were bent back about a foot, and the lower vertical stabilizers took some serious damage as well. This unfortunate accident forced them to push back the first actual flight by almost 3 full months. To fix the clearance issue, designers had to slightly lengthen the aircraft's main landing gear struts. However, the most important modification, meant to permanently protect the propeller from dangerous ground strikes during takeoff, was the installation of small auxiliary wheels. These were rigidly mounted to the bottom of the vertical stabilizers and did not retract during flight. In the documentation, this clever engineering setup got its own name, the Shiragiku landing gear. The first flight was repeatedly delayed due to severe shortages and late deliveries of essential equipment and spare parts. On top of that, engineers and designers were seriously concerned about the engine overheating while the aircraft was idling on the ground. Despite these hurdles, that historic first flight finally took place on August 3, 1945, at the Mushiroda airfield in Fukuoka. To minimize risk to the prototype, they installed mock-up dummy cannons instead of the actual armament and kept fuel and oil levels to an absolute minimum. Kyushu's experienced test pilot, Yoshitaka Miyaishi, took the controls of the unconventional aircraft. The flight itself ended up being very short but revealing. The fighter successfully lifted off the runway at around 105 knots. After climbing to an altitude of 1,300 feet, the aircraft accelerated to 140 knots. At that point, the pilot made a turn and came in for a safe landing. Although the overall results of this first test were considered generally satisfactory, some serious aerodynamic flaws became apparent in flight. The biggest issue was the massive torque from the large pusher propeller. This torque pulled the aircraft sharply to one side during rapid acceleration. The short fuselage and undersized vertical stabilizers only exacerbated the problem. This torque also caused severe asymmetric airflow over the wings. For the pilot, this made it virtually impossible to properly trim the aircraft during takeoff and landing. On top of that, a landing speed of 130 knots was considered dangerously high by the design team. Instruments also recorded severe vibrations coming from the extended propeller driveshaft. 2 additional test flights took place on August 6th and August 8th. These flights only confirmed these initial findings. Altogether, across these 3 test flights, the new prototype spent a total of just 45 minutes in the air. The maximum altitude reached during testing was around 1,600 feet. The top speed never pushed past 140 knots. During the second and third flights, engineers also noted a few structural defects related to the wing design. And it needs to be said plainly, during the takeoff and landing phases, the fighter proved incredibly difficult to handle. Only highly experienced veteran pilots could fly it safely. Japan had very few of those left by the late stages of the war. Despite these early growing pains, the design team agreed that the flaws could be ironed out relatively quickly and that the aircraft had every chance of becoming a highly capable interceptor. However, the abrupt end of the war prevented those ambitious plans from becoming a reality. While the Japanese did manage to complete a second prototype, it was never destined to fly. On top of that, engineers already had an improved version of the fighter on the drawing board. This was the J7W1 Shinden. The plan was to equip this variant with the brand new NE-130 turbojet from Ishikawa-jima Shibora. This engine would have produced nearly 2,000 pounds of thrust. In September 1945, American forces took control of the Mushiroda Naval Air Base in Fukuoka. Among the 145 different aircraft captured at the airfield was one of the 2 Shinden prototypes. At the time, the aircraft was heavily damaged and its engine was missing entirely. American personnel carefully dismantled the unique airframe and shipped it across the Pacific to the United States. It was destined for Wright Field, known today as Wright-Patterson Air Force Base. With the help of Japanese specialists brought in for the project, the fighter was fully restored and put through an extensive flight test program. The results genuinely impressed the American engineers. They were highly interested in the handling characteristics of an aircraft built with such an unconventional aerodynamic layout. What surprised them the most was its incredible maneuverability. Once testing wrapped up, the fighter was transferred to Naval Air Station Willow Grove in Pennsylvania. From there, in 1960, it was moved to the Smithsonian Institution. Today, you can see this rare Shinden for yourself at the Paul E. Garber facility in Maryland, a part of the National Air and Space Museum in Washington, D.C.